Good morning once again. The derivation of induced current and induced charge. What is induced current? Induced current is defined as the current induced in the conducting loop that is exposed to a charging magnetic field is known as induced current. It is the explanation of the Lenz's law. This derivation is defined by the Lenz's law. Lenz's law states that the direction of induced current in a circuit is such that it opposes the cause or the change which produce it. Okay, children? And Lenz's law also defined as the law of conservation of energy. Whether a magnet is moved towards away from a closed coil, the induced current always opposes the motion of the magnet as predicted by Lenz's law. For example, when the north pole of magnet is brought closer to the coil, its face towards the magnet develops north polarity and thus repels north pole to the magnet. Work has to be done in moving the magnet closer to the coil against the force of repulsion. Similarly, when the north pole of the magnet is moved away from the coil, its face towards the magnet develops south polarity and thus attracts the north pole of the magnet. So children, this derivation is induced current and induced charge. We know that if a coil of n turns, the rate of change of magnetic flux delta phi b upon delta t, then the induced EMF in the circuit is equal to minus n delta phi b upon delta t. Children, we know that if the coil close and total resistance of its circuit be R, then the induced current in the circuit will be I equal to E upon R. Children, it is the formula of current I equal to E upon R. On putting the value of E from above equation, therefore I equal to minus n delta phi b upon delta t. Children, so therefore current will be n upon r delta phi b upon delta t. This equation indicates that the induced current in the circuit depends upon the resistance, whereas the induced EMF is independent of resistance. The charge flowed through the circuit in a time interval delta t will be given by Q equal to I into delta t. It is the formula of charge. Charge where Q is the charge, I is the current, delta t is the time interval. Children, on putting the value of I in this equation, therefore Q equal to I into delta t, where I is equal to n upon r delta phi b upon delta t into delta t. Okay children, therefore value will be Q equal to n upon r into delta phi b upon delta and into delta phi b, where n is the number of turns. Children, n is the number of turns, r is the resistance and phi b is the change in magnetic flux. Okay children, substituting the delta phi b in Weber, we know that the unit of delta phi is the Weber, r is the ohm. Q will be in Coulomb. The above equation shows that the induced charge does not depend upon the time interval. Whether the change in magnetic flux be rapid or slow, the charge in the circuit will remain in the same.